Okay, today in our investigation, we are going to look at what effect the transformations applied to a exponential function of the general form will have. So we've got our exponential function of the general form. That is f of x is equal to a times b to the x. As we know, f of x is going to be proportional for all values of x. When we apply our transformations, we've got our vertical dilation here. We've got our horizontal dilation. We've got our horizontal translation, h, and k is our vertical translation. Well, questions we're asking ourselves today is, of those different transformations, which ones of them will have an effect of creating g, which is proportional still? Remember that f is proportional for all x. Will g be proportional, and will it still be proportional by the factor of b? That's our investigation we're looking at. So we'll start off by looking at it in GeoGebra, and we'll see what happens as we apply our vertical dilation first. So into GeoGebra, I've got this. So we can see the two functions. At the moment, I've got the vertical and horizontal dilation set at 1, which creates no effect. I've got the vertical and horizontal translations at 0, which has no effect. So if we change C now, we're going to apply a vertical dilation. We should see a stretch. We see a stretch. We see a compress. So it vertically dilates by a larger factor. So here we're dilating by a factor of 2. Do we have an effect on whether it's still proportional? So I've made up a little spreadsheet over here to the right. Let me pull this one out. In this first column here, we see the x values 1 to 10. In our second column, we see the values of g of x. These are the output values that we're getting. And then lastly, in column C, and that's what we're interested in, these are the quotient of consecutive values. So we can see that with the quotient of consecutive values here, this one is proportional with a factor of 2. Now, if I change the vertical dilation, will that 2 change? Notice that the output values change completely as I'm doing this, but the fact that their consecutive values are still proportional by the factor of 2, we can see it quite clearly. So what we're seeing here in this one is that when we apply the vertical dilation, it is still going to be proportional by a factor of b. Let's take the horizontal dilation now. So as I change my horizontal dilations, notice that the curve is dilating horizontally. In this case, it's changing the factor. It's still proportional, but by a different factor. So when I apply a horizontal dilation, it's still going to be proportional, but by a different factor. Let's pop this one back to 1. Okay, horizontal translation. If I move it right and left, oh, sorry, I'm moving the wrong one. If I move it right and left, here we go. Moving it right and left. If I move it to the right, move it to the left. Notice that it's having no effect on whether it's proportional, and it's actually proportional still by a factor of 2 all the time. It doesn't change the shape of the curve. So horizontal translation, still going to be proportional by a factor of b. And our last one is going to look at the vertical. As we translate vertically up and down, look at this column C over here. We're getting a different proportionality. If k is not equal to 0, we are going to get a different proportion. It's not going to be proportional. Not going to be proportional. K is any other value than 0. So this one is a no. Right, we're going to do a little investigation on that and have a look why. Why is this the case? So we have our function, g, choose a smaller pen. We have g of x is equal to c times f of b of x minus h plus k. If we insert function f, we get c times a bracket times b to the, oh, sorry, that was not b. I'm using a d there, aren't I? This one's a d, times dx minus h plus k. So I've put the function f in. If you remember, f is equal to a times b to the x. Okay, so what can we do with this? I can rearrange this a little bit now. And this is going to be c times a times b to the dx over b to the h plus k. And I'll rearrange it a little bit more. I can extend this line across, and I can move this constant over here, and I can split these two up. Let me show you how that's going to look. I get c times a over b to the h times b to the d to the x plus k. And I've expanded and moved my constants around a little bit, tidied it up, and I'm going to show you why. So our next term in the sequence would be, therefore, g of x plus 1, which is going to be equal to c times a over b to the h times b to the d to the x plus 1 plus k. Our common ratio is made by taking g of x plus 1 divided by g of x. If I just take these, there. Okay, so looking at this, if we wish to simplify this, we cannot. And we can't because of these k values at the end. We can't make any simplification here because of those k's. And that's because we don't have a common ratio when we have k. It's going to be dependent on the every value in this sequence is going to change as x changes. And we saw that here in the spreadsheet, here in this column. For every different x, we're getting a different common ratio when we have a k value. So if we take k and we set it equal to 0, we're going to get a common ratio. So we have to do this algebraically. So in order to have a common ratio, k must equal 0. And what that will do is it will take this out of our equation like this. Okay, so now we can see how this is going to simplify. If we wish to simplify this, we can see that we have a constant here at the front. So this term here is a constant, and this term here is a constant. There's no x in it, so it's just going to be a constant. And constant divided by a constant will cancel. So that will give us b to the d to the x plus 1 over b to the d to the x. Now, we can simplify this further using the laws of indices, b to the d to the x times, using the exponent laws, sorry, b to the d to the x on the denominator. Now, we're going to be able to simplify further because we've got common factors here. These two factors can cancel. So our common ratio is simply going to be b to the power of d. This is why, if we remember back at the beginning, c has no effect on the proportionality factor. H has no effect on the proportionality factor. K completely eliminates it and means there's no proportionality, and D will have this effect on it. It will just, the new proportionality factor will be B to the D. So, in summary, this is what we need to remember is vertical dilations, horizontal translations will not change the proportionality factor of the general form. Horizontal dilation will still be proportional, but it will change the factor. And vertical translation, no, it's not gonna be possible. So just moving that along a little bit, we have one more thing to look at today, and it's this, the additive transformation of exponential functions. So let g of x equal f of x plus k. That's what we've just been looking at. What happens when we have a k? This means we take a function f and we add something to it, we shift it to the graph up or down. The function f is having k added it to create g. If the output values of g are proportional over equal length input values, then f is an exponential function. So this is, as what we've seen is, if you add k to it, it's not going to be proportional. So if f was proportional and you add k to it, g won't be. If f was not proportional, but it was some exponential function, and you add k to it, and we find that g, well, this one's actually going backwards. This one's saying that if this is proportional, it's because f must have been an exponential function. You can't take any exponential function and add k to it and create a proportional one. F of x has to be of the form with minus k at the end in order for the two k's to cancel out and create this proportionality. But it is something that we're going to look for in the questions, that if g is proportional over equal length input intervals, then f was an exponential function. It doesn't mean that f was an exponential function in the general form, because it would also be proportional, and with this additive transformation, it's not possible to create two proportional functions, f and g. Either both aren't proportional, or f is proportional and g is not, or g is proportional and f is not. Okay, that's it for this one.